Robots built for war. AI is pushing the limits of what's possible, and tech companies are diving deeper into defense. Things are moving fast, and it's getting wild. From a humanoid war machine making its debut in a San Francisco nightclub to AI research agents that could replace hours of work in minutes, there's a lot to unpack. Imagine this: a humanoid robot designed for war makes its first public appearance, not on a battlefield, but on stage at a nightclub in San Francisco. That's exactly what happened with the Phantom MK1, a robot built by a startup called Foundation Robotics Labs, based in Frisco, Texas. They introduced the Phantom MK1 at Temple Nightclub during an event called the Quarter of the Century Tech Giga Party. People at the event saw the robot DJing on stage. But here's the catch: its movements and music selection were all pre-programmed by humans behind the scenes. It wasn't fully autonomous, but it was still a bold statement. Foundation Robotics Labs was founded in 2024 with about $1 million in seed funding. The founder, Sanate Patak, is no stranger to startups. He previously ran a fintech company called Synapse, which went bankrupt. Now he's teamed up with Mike LeBlanc, a former US Marine and co-founder of a security robotics company called Cobalt AI. Together, they're building humanoid robots for everything from manufacturing to military use. And they're not shy about their defense ambitions. Patak believes advanced humanoid robots will be essential in future warfare. He's been vocal about the need for the US to keep up with China's push in defense robotics. As one reporter put it, the Phantom MK1 is a literal war machine. Let's break it down. The Phantom MK1 stands about 5 feet 9 inches tall and weighs around 175 pounds. It can lift up to 44 pounds and is powered by advanced cycloid actuators. These actuators combine the power of hydraulics with the efficiency and quiet operation of electric motors. This means the robot can deliver peak torque of around 160 Newton meters while maintaining precision with a back-driving torque of under a single Newton meter. The robot's upper torso acts as its central command center, packed with batteries, processors, cameras, and sensors for 360-degree awareness. Its lower torso is designed for balance and mobility, allowing it to navigate uneven terrain, climb stairs, and move through tight spaces. It even has a human-like gait so it can work in factories, offices, or disaster zones. Interestingly, the core technology behind the Phantom MK1 comes from Boardwalk Robotics, a small Florida company that introduced a humanoid robot named Alex in 2024. Alex relied on a stable base for advanced manipulation tasks, but the Phantom takes things further with a more complex lower body and improved mobility. Foundation Robotics has ambitious goals. They plan to ship over 40 robots in 2025, ramping up to 10,000 in 2026 and more than 20,000 in 2027. They're targeting $1 billion in annual revenue, a huge goal for a startup that's only been around for a year. And they're dreaming big. They want to use those profits to build a base in Antarctica and eventually expand to the moon and Mars. This trend isn't unique to Foundation Robotics. More tech companies are getting comfortable with defense applications. Even big players like Meta, OpenAI, and Google have started reversing their anti-military stances. For example, Boston Dynamics worked with DARPA years ago on a humanoid robot called Petman to test chemical protective suits. Then there's Atlas, originally designed for disaster response but now used for industrial tasks. Russia also introduced Fedor, a humanoid robot allegedly for space missions, but it could also carry firearms. Switching gears, let's talk about a collaboration between NVIDIA and Carnegie Mellon University. They've developed a framework called ASAP, aligning simulation and real physics. The idea is simple: train robots in virtual environments where they can push their limits without risking damage in the real world. ASAP helps ensure that what robots learn in simulations translates more accurately to real-world physics. The results are impressive. ASAP reduces motion errors by about 53% compared to older methods. They tested it on a G1 humanoid robot, having it perform forward jumps of over a meter. Unfortunately, the team faced some hardware issues. They pushed the robot too hard, overheating some motors and damaging 2 test units. But they're staying optimistic, saying every failure is an opportunity to improve. Plus, they've made their code open source on GitHub, so other developers can build on it. Now let's take a closer look at Adam, an extraordinary humanoid robot developed by P&D Robotics. Adam has been capturing the imagination of people worldwide with its remarkable dexterity and ability to perform tasks that require incredible precision, such as calligraphy, a skill that demands not only steady hands, but also fine motor control. Building a robot like Adam is no ordinary feat. It's a highly intricate process that takes approximately 37 hours of meticulous work. This involves cutting-edge techniques like 3D modeling, CNC machining, and other advanced manufacturing processes that ensure every component is crafted to perfection. Adam is designed with 37 degrees of freedom, giving it an unprecedented range of motion that mimics human capabilities. It is powered by 20 high-performance actuators, which allow it to handle delicate and complex tasks with ease. Whether it's assembling tools, balancing objects, or performing intricate maneuvers, Adam executes these actions with a level of precision and fluidity that is truly impressive. At the heart of Adam's operation is the proprietary P&D PMC system, a sophisticated control mechanism that seamlessly coordinates 163 CNC machine parts and nearly 400 printed components. To achieve this level of engineering excellence, P&D Robotics employs 7 different composite materials and utilizes 13 specialized manufacturing processes, all of which are carried out entirely in-house, showcasing the company's commitment to quality and innovation. One of Adam's most groundbreaking features is its imitation learning framework, which allows the robot to learn locomotion by analyzing real-world human movement data. This cutting-edge technology enables Adam to replicate human-like motion with remarkable accuracy, resulting in movements that are far more natural and agile than the rigid mechanical steps seen in older humanoid robots. By studying how humans walk, balance, and interact with their environment, Adam can adapt and refine its own behavior, setting a new standard for what humanoid robots can achieve. As you can see, the world of robotics is undergoing a revolution, with innovation happening at an unprecedented pace. Companies like Foundation Robotics are addressing global challenges such as labor shortages and exploring applications in defense, hoping that their flagship model, the Phantom MK1, will spearhead the rise of mainstream humanoids capable of handling virtually any task, from mundane chores to potentially even combat scenarios. Meanwhile, academic institutions like Carnegie Mellon University and tech giants like Nvidia are bridging the gap between simulation and reality, allowing robots to train in virtual environments before deploying them in the physical world. This approach significantly accelerates development and ensures smoother real-world performance, reducing the time and cost associated with traditional trial and error methods. On the other hand, P&D Robotics is setting new standards for dexterity and adaptability with its advanced imitation learning systems, proving that robots can mimic human behavior with astonishing accuracy. These advancements are pushing the boundaries of what humanoid robots can achieve, from intricate manual tasks to fluid, lifelike movements. The implications of this technology are vast, ranging from improving productivity in industries to enhancing the quality of life for individuals who rely on robotic assistance. On the software side, companies like OpenAI and Google are in a race to develop the most advanced autonomous research agents. These AI-driven tools have the potential to provide robots with real-time information, enhancing their ability to perform tasks more efficiently and effectively. Imagine a future where humanoid robots walk through factories, handling fragile components with care, or even operating in extreme environments like Antarctica, defending remote outposts, or conducting scientific research. Such robots could be deployed in disaster zones, space exploration missions, or healthcare settings, offering solutions to some of humanity's most pressing challenges. While some may view these developments as the next step in technological evolution, others might find them unsettling, fearing they could lead to unintended consequences or even dystopian outcomes. For instance, the increasing reliance on humanoid robots in various sectors raises questions about job displacement, ethical considerations, and the potential for misuse in military or surveillance contexts. Despite these concerns, one thing is undeniable: the pace of progress is accelerating rapidly, and the possibilities are endless. The convergence of robotics, artificial intelligence, and advanced manufacturing is reshaping industries and redefining what it means to be human in a world increasingly shared with machines. Thank you so much for joining me on this incredible deep dive into the fascinating and ever-evolving world of next-generation robots and artificial intelligence. It's truly an exciting time to be exploring these groundbreaking advancements as we witness the convergence of cutting-edge technologies that are reshaping industries, redefining human capabilities, and pushing the boundaries of what we once thought was possible. If you found this exploration insightful, inspiring, or even a little mind-blowing, I'd greatly appreciate it if you could show your support by hitting that like button and subscribing for more updates. Your engagement helps us continue to bring you content that delves into the latest innovations and discoveries in robotics, AI, and beyond. We've only just scratched the surface of what's possible in this rapidly advancing field. From humanoid robots like Adam, capable of performing delicate tasks such as calligraphy with astonishing precision, to futuristic visions of machines exploring distant planets or assisting in extreme environments like Antarctica, the potential applications are limitless. Imagine a world where robots not only handle mundane chores, but also contribute to solving some of humanity's greatest challenges. Whether it's addressing labor shortages, aiding in disaster relief, advancing space exploration, or revolutionizing healthcare, the journey of innovation is far from over, and every new development brings us closer to a future that feels like it's straight out of science fiction. As we look ahead, I'm genuinely excited and sometimes even a little awestruck to see what the future holds. Will we one day live alongside humanoid robots that can seamlessly integrate into our daily lives? Will AI-driven systems become indispensable partners in scientific research, creative endeavors, and problem solving? The possibilities are as vast as they are thrilling. Thank you once again for taking the time to watch, learn, and engage with this content. Your curiosity and enthusiasm make these discussions all the more meaningful. I hope you'll stay tuned for more explorations into the incredible world of technology, because trust me, the best is yet to come. Thanks for watching, and I'll catch you in the next one.